very easy or very fundamental questions. It is asked in the many types of university examination if you are studying in the mechanical engineering, and there is a questions in the many types of university exams. So as we know, the fluid flow, what do you mean by fluid and what do you mean by fluid flow, as you know very well. So in the today's lecture we will learn the fundamental of types of flow. Types of flow, it means which type of flow occurs in the real life applications. The first of all, here the first is types of flow. First flow or types of fluid flow is called, somewhere write down the types of fluid flow. The first types is steady and unsteady flow. It means steady and unsteady flow. It means steady means time constant. With respect to time, there is no changes is happen. Or in the unsteady flow, time is not constant. Okay. So the velocity of the fluid flow with respect to time at the place x, y and z is equal to 0. There is no change in velocity with respect to time for the steady flow. But similar in the unsteady flow is nothing but change in velocity with respect to time is not equal to 0. So steady flow is defined as that type of fluid flow in which the fluid characteristics like velocity, pressure, density, etc. at a point do not change with respect to time. Any property of the fluid which is not change with respect to time, it is called the steady flow. And here the example of as a property like velocity. But if the property is changing with respect to time, then it is called the unsteady flow. Now, second, uniform and non-uniform flow. What do you mean by uniform and non-uniform flow? The name suggests uniform flow. It means there is a same cross section at inlet and outlet of the flow. So here it is called the uniformity flow. And here the change in cross section at inlet and outlet, then it is called the non-uniform flow. But if we express in the form of mathematics, then change in velocity with respect to s means space. Here time is constant is equal to 0 and del v by del s, change in velocity with respect to space, time constant is not equal to 0. It means non-uniform flow. Here s is nothing but the space coordinates. Space coordinate. It means here the velocity is v, so here the velocity is v. It means uniform. Here the velocity is v, but here is not v, like v1, v2, v3. It means the value of v1, v2 is more or less than the v, but it is not similar there. Similar that of the velocity v. Now, the third is laminar and turbulent flow. Applications or laminar and turbulent flow. In that laminar flow, there is a layer by layer flow of fluid occurs. There is no randomness in the flow. All layer passes over the adjacent layer, then it is called the laminar flow. But in the case of turbulent, there is a turbulence occurs. So not attached with adjacent layers. It is in random motion, and the random motion, then it is called the turbulent flow. Okay. Now fourth, compressible and incompressible flow. What is compressible? What is incompressible flow? Compressible means density is not constant. Here, density of the fluid flow is constant. It means the molecular vibrations, molecular vibrations change the density. In this case, there is a no change in density due to the molecular vibrations. So, examples of the compressible flow are compressible fluid are air, gas, and for incompressible fluids are water, oil, are incompressible fluids. Fifth, rotational and irrotational flow. Rotational means there is a axis rotation and also axis center point revolution. It means there is a fluid element like that. For example, this is the fluid element like that. This is the center point of the fluid element. A center point about the fluid element is moving about its own center like that. The fluid element is like that in the motion. So it is motion like that, like that, like that. So fluid element is move around the center of its own axis and also about the center of the fluid flow. So it is called the rotation. But in irrotation there is no rotation about its own axis. Rotation about its own axis. Is it clear? Six, 1, 2, and 3 dimensions. Fluid flow. Okay. Here there is no visibility of this point. Means rotation about its own axis is not permissible. 6, 1, 2 and 3 dimensional fluid flow. It means for the one dimensional there is a velocity or u is a function of only x, v 0, w 0. For the 2 dimensional there is a u is a function of x and y, u is a function of x and y, v is a function of x and y, but w is 0. For the 3-dimensional flow, velocity u is a function of f, x, y and z, v is the function of f, x, y and z, and w is also the function of f, x, y and z, where u, v and w are the velocities in x, y and z as a velocity in x direction, v velocity in y direction and w velocity in z direction. So This is all about types of flow, fluid flow. In this, there is a one examples of the uniform non-uniform flow is remaining. So I can say that uniform flow is nothing but the pipe flow. Uniform pipe flow. It means uniform pipe flow is called uniform flow whenever the diameter is constant. Inlet and outlet diameter is constant. Pipe flow. And nozzle and diffuser flow is a non-uniform flow. Nozzle and diffuser flow is a non-uniform. So, is it clear to all? Types of flow: steady and unsteady flow, uniform, non-uniform flow, laminar, turbulent flow, compressible, incompressible flow, rotational and irrotational flow, and 1, 2 and 3-dimensional fluid flow. Thank you friends for watching this video. I hope this content it will be helpful to you. If you would like to watch these types of more technical videos, then please subscribe our Techno Education Academy and also share with your friends. Thank you.